From time to time, batteries make the headlines because they are expensive. And then they make the headlines because they have gotten cheaper. So which is it? It's like watching a horse race, where the commentator gets excited every time when a different horse takes the lead. Although this might be entertaining, it's not very useful. In order to figure out where things are heading, this video looks at the changes in prices over multiple decades. This information is then used in an attempt to predict future prices. Before talking about battery prices, let's talk about solar panel prices. Solar panel prices have declined by 99.6% since 1976. In this plot, you can see the price of solar panels per watt. This curve is called a learning curve. The idea is that the price declines because people are learning how to make the panels more efficiently. And more efficiency means less waste, which means lower costs. Since the decline is exponential, it's hard to see the trend. Let's fix this by plotting the price on a log scale. With the log scale, it's easier to see that the price has kept declining at a consistent rate. After doing the math, it turns out that the price decreased by about 12% per year. But these plots still don't show the full story. The price decreases exponentially, but what does that mean? Does that mean that the decreases in price are less impressive each year? Let's look at the price in another way. Here we flip the vertical axis around to show not dollars per watt, but watts per dollar. For example, let's say we want to put solar panels on a house and have a budget of $10,000. In 1976, we could have bought about 77 watts of solar panels. That would mean you could power a 1980s light bulb when the sun is shining. In 1990, the same budget would have bought about 800 watts. Enough energy to power a vacuum cleaner. In 2010, the same budget would have bought about 4,000 watts. Enough energy to power 4 vacuum cleaners. Today, the same budget buys you about 32 kilowatts. That means you can power 32 vacuum cleaners. Or an industrial air conditioning unit. Or you can recharge an electric car in about 3 hours. Just like solar panels, the prices of batteries are declining exponentially. In 2013, the price for a battery pack per kilowatt hour was about $780. Today, the price is about $100 per kilowatt hour. Let's look again at a log scale to see the trend. This looks fairly similar to the solar panel plot. Although the line goes up and down, the overall trend seems quite consistent. Let's plot a line from the first point to the last point. The line looks like a reasonable fit for the data. In doing the math, it turns out that the price decreased by about 17% per year. If we continue the trend, the price will go to about $32 per kilowatt hour in 2030. So what does that mean for the cost of an electric car? Say we want to build an electric car with a reasonably big battery of 70 kilowatt hours. In 2012, this would have cost about $54,600. No wonder that electric cars sold for at least $100,000 back then. Today, the same battery will cost about $7,000. And indeed, electric cars now sell for about $40,000 when you exclude subsidies. With a price of $32 per kilowatt hour, the battery will cost about $1,200 in 2030. That is very promising for the price of future electric cars. Is this prediction reasonable? Will battery prices continue to drop? Given the history of other technologies, it does not seem unreasonable. For example, hard disk drives have also become orders of magnitude cheaper over the last decades. You could have said in 1988 that disk drives could not get any cheaper. And that would have been incorrect. The price got 1,000 times cheaper by 2000. And then you could have said that they could not get any cheaper, and that would have been incorrect again. The price got 100 times cheaper by 2010. Other technologies have also become consistently cheaper over time. For example, DNA sequencing has become 10,000 times cheaper since 2000. Solar panels, as we have seen, have become 400 times cheaper since 1976. Not only are there multiple technologies that have steadily decreased in price, but the changes in battery materials are promising as well. Battery manufacturers are still experimenting with the best materials to use for the battery. In the last years, the production has switched from NMC to LFP. LFP batteries do not contain nickel or cobalt, both of which are expensive and rare. Given that this switch was so recent, it is likely that there is still a lot of room for improvement.